Hello, Science 7. This is part 2 of our electricity content. The thing we're going to talk about in today's slideshow is electric current. Now, you understand the word current if you've ever watched the movie Finding Nemo. You remember the turtles riding that current through the ocean. So, in the movie, that is a water current or an ocean current, but electricity or electric charges can also flow like an ocean current. So anytime electric charges flow continuously through a material, we call that an electric current. Okay, what is an electric current? So for example, this little diagram, it shows you, the arrows show you the direction of the electric charge flow. They're leaving the negative end of the battery and flowing through the wire to light the light bulb and then back around to the battery. So that is an example of electric current flowing through a circuit. Now, electric current is a quality that we can measure. And the unit of measurement that we use for that is an ampere. Sometimes it's abbreviated amp. And the actual abbreviation for that unit of measurement is a capital A. Now, this is a measure of the amount of charge or electric current that will pass through a wire during a certain amount of time. So it's a rate of electric current. So how much of the charge is flowing, for example, past a certain point on an electric circuit each second, and that is amps. Okay? We also need to understand electric currents. You're going to be doing some hands-on work with this to get us ready to build our rovers. Electric circuit comes from the word like an unbroken path, like a circle even. Okay? So an electric current is a complete and unbroken path that electric current flows through. Now, any kind of electrical device or appliance that you have, refrigerator, computer, TV, rice cooker, they all have electrical currents. And you can touch them and you can touch their cords and unplug them because the materials that make up electric circuits are different. So let's talk about a couple of different ones. First of all is conductor. You guys are familiar with this word even from our chemistry study. You know that metals are good conductors of thermal energy, and they're also good conductors of electrical energy. So anytime you have a material that electric charge will flow through easily, that will carry an electric current, we call that a good conductor. And they are usually good conductors, and you will understand this because of the chemistry unit, is because they have a lot of loosely bound electrons. They have electrons that are kind of out and about and ready to bond or be involved in this electric charge. Okay, and so metals are all good conductors of electricity, and that's why they're often used in wiring to carry current. Now, another material we have to talk about are insulators, and this is the opposite of conductor. Now, why did I use the same picture? Because in this picture, I want you to focus on the covering of the wire. So you've got each wire is covered, and then you actually have a pipe or conduit that they are running through. These materials, these insulators, are used on the outside covering around cords for electrical devices because they don't allow the charge to move freely. They don't allow electric current to flow well. Okay, another part of the circuit we need to talk about is the energy source. What's happening is you have potential energy in the battery, and then the electric charge is flowing through the circuit to power something. So it's becoming kinetic energy or moving energy. In this case, the car battery will provide the charge that's going to run the engine or the motor. So it's going to change into motion. It's going to turn into sound. You're going to hear some sound energy and also some thermal energy. Okay, another example would be these small AA batteries. They have potential energy, and that potential energy is converted to kinetic energy in the flashlight because you have light and also a little bit of thermal energy as well. All right, another quality of electric current that we need to talk about is voltage. Voltage is another unit of measurement, and it has to do with the difference in electrical potential energy per charge between 2 points in a circuit. Now, I don't understand that really well either, and we're going to make Mr. J explain that fully, and we're also going to be practicing with building different circuits. So hopefully we'll have a better understanding of this. But just to give you some idea, voltage in lightning is typically anywhere from 10 to 120 million volts. So you can understand just from that how different the amounts of voltage can be, and why maybe a watch battery is only a couple of volts, or a car battery is a lot more. Another thing that we have to consider when we're talking about current is resistance factors. Now, the amount of current that can flow through a circuit depends on the voltage, but it also depends on the resistance of the circuit. And some of those are one diameter. So think about this: if you have a straw from the smoothie stand, one of those skinny ones, and then you have one of those big fat ones that has a big diameter, which one can you suck more smoothie up through? Well, the one with the greater diameter. So the wider the wire, the bigger the wire, the less resistance and the easier the current's going to flow through it. Okay, another factor is length. The shorter the length, the less the resistance. So we've got two straws that appear to be the same length, but because of all the curves in the one on the left, it actually is longer. So it's going to take more energy for you to suck the smoothie up through that straw. So length is also a factor in resistance. Another would be the material. Remember, we talked about conductors and insulators. So the better the conductor, some conductors are even better than others. For example, copper wire is considered to be an excellent conductor of electricity, and so it's often used in wiring for houses. And if the material is a really good conductor, then the flow of electricity, the electric current, is going to move a lot faster and more easily through that material. Another factor is temperature. And there is a direct relationship between temperature and resistance. The higher the temperature, the higher the resistance. The lower the temperature, the lower the resistance. So that's why you might want to think about having your electrical appliances in a cool place. You want to make sure your computer has air circulating around it and things like that. All right, so those are the key points that you need to know about electric current. I hope this has been helpful. Thank you very much.